Hello, everyone, and a warm welcome back to all of you. So, participants, currently we are focusing on the container aspects involving Dockers and Kubernetes. And Dockers and Kubernetes, currently we are implementing on top of the cloud. So, participants, in the previous session, you have seen the idea of turning a simple source code into a Docker image, which has been built by bundling all the packages like the var packages that we had and the application that is required to run this var packages, which is Tomcat, bundling together and exposing the port 80 using the Docker file. And we were able to go ahead and build the Docker images. So right after building the Docker images, the next step is to go ahead and deploy those Docker images. We have to start focusing on the deployment of those Docker images. When it comes to the deployment, we need a cluster to deploy it. Cluster means set of servers more than two. That set of servers should get scaled enough as and when required, descaled when they are not required. Traffic distribution should take place. Automatic deployment should take place. Load distribution should take place. Health should be checked across those instances. So there are plenty of things that have to be done. There are many things that have to be taken care when it needs to deploy an image, because we will focus on a production based environment. So when we focus a production environment, imagine how many things have to be taken into consideration. So that is where the software comes into picture, the system comes into picture called Kubernetes. So Kubernetes, as you have seen as a definition from the official documentation, it's a software or a system that is available for automating the deployment, scaling, and productionizing the container apps. So now we will go ahead and start a little about Docker. We'll start to understand a little about Kubernetes. And then we will start understanding why we use Kubernetes and what is the architecture of Kubernetes and how to start doing deployments into the Kubernetes architecture involving a cloud platform. So participants, you all know that Kubernetes is a container orchestration tool. Orchestration means if you have a set of image or images that are built, which are container image, when you want to deploy into a cluster, the cluster needs to get customized according to your need. Then we call it as container orchestration. So Kubernetes is the world's popular container orchestration platform. A lot of organizations use Kubernetes. They develop applications in the form of container apps and they deploy across this Kubernetes cluster. So as a DevOps engineer, you are required to know how to build Docker images or container images, the top priority. And next, as a DevOps engineer, you are expected to go ahead and learn how to do deployments into Kubernetes clusters involving EKS. So participants, now it's time for us to go ahead and start taking back the steps. In the last session, you have seen how did we go ahead and install Docker, and with the help of the container engine Docker, we were able to successfully build a Docker image. So that Docker image is now going to be used to deploy into Kubernetes cluster. That means now we have to have a Kubernetes cluster. So in order to understand how to do a deployment, we need to understand a little about Kubernetes architecture, how this cluster or what exactly the cluster would comprise of. So participants, I have taken this entire discussion of Kubernetes cluster architecture into a 3-node cluster. It doesn't mean that there are only 3 nodes for your information. It's just to give you a view, a hypothetical. I would say this is just a way to visualize, assuming that there is a 3-node cluster. In a 3-node cluster, one will become the master and the other 2 will become the worker nodes. Master is the brainer of this entire cluster, and the worker nodes are those where actually they'll do the computation. So the one that you can see here, starting with UI or CLI. UI means user interface, web UI, we call it as. CLI, command line. So we can use UI or we can use CLI. This is basically dashboards. So Kubernetes dashboards you can use, or Kubernetes CLI. You can connect via a service called API. There is a service in Kubernetes on the master side where you can go ahead and via this API, you can start looking into Kubernetes cluster, what is happening inside Kubernetes. So you can give commands to the master. Kubernetes using CLI, I will write kubectl. Can you get me the nodes? So an example. So via a CLI command, I can ask kubectl, can you get me the nodes? kubectl, can you get me the nodes? kubectl, can you get me the deployment? So this is CLI mode. So we'll write a command. Via the command, we will talk to Kubernetes cluster. I'm going to show you in some time once the cluster is ready. Next, we have control manager. As the name itself says, control. It does control the jobs in the backend. Then who will go ahead and assign the jobs? Scheduler. If someone is managing, there should be someone to schedule a job. That's what a scheduler. Then what is HCD? HCD is the database where Kubernetes does store its data. Now from the master side, if you go to the node side, you'll find something like pods actually running the container running the images running your application. We'll explore a little more about pods. So a little more about the API configuration. So API server has 2 things. Please remember, web dashboards or web UI. That means via using UI commands or using interface, you will get connected to the cluster and perform the operations. And kubectl is all about the CLI method. Just now I was highlighting about it. So kubectl is the way to connect to Kubernetes cluster. So there is a Kubernetes cluster running, maybe inside your machine or on cloud. You will use kubectl. 100% you will be using kubectl. And I would recommend you participants to use kubectl. kubectl is the recommended way to talk to your Kubernetes cluster. How? Kubectl get me nodes, get me pods, get me deployments, get me services. So kubectl is the way to connect to the Kubernetes cluster. Now the question should be asked by you, Kumar, how does kubectl know to which Kubernetes cluster it should, or how does it go and connect? So once you create Kubernetes cluster in your system, there will be a folder or there will be a file called KUBE file. Basically, it's a folder. It's a hidden folder. Inside that, there will be a file called config. The system will create. Inside this, it has the cluster information about Kubernetes, K8s, Kubernetes. So when you go ahead and use kubectl, so kubectl, first thing it will do is it will hit your folder and the config file and the K8s information. Based upon this, it will start getting access to the Kubernetes cluster. Are we good, everyone? I'm going to show you that as well. This .kubec, .kube file, .config file. From there is another important keyword which is called kubelet. What is kubelet? Kubelet is nothing but, as you are already aware now from the architecture, there is a master and a worker node concept. So master worker node, how should they interact? An agent should be running on a slave or the worker node. So agent, we call it as kubelet. So kubelet is the agent that is running on your worker node that allows or that takes the update regarding the health, the working status of the node to the master. Participants, are we good now with these concepts involving Kubernetes master? Are we good to proceed further involving nodes, pods, deployments, and services? Do you have any questions that I can answer? If you're not getting clarity about these topics, please feel free to ask me. I'll try my best to make it more clearer for you. If you're good enough, then can we move to the next? Okay, participants, to just like give a quick revision of the topics once more time. So we have started exploring Kubernetes. Kubernetes is a system which primarily deals with deploying container apps. Whatever the container apps you develop, it deals with the deployment. So container apps, in this current scenario, we are using container technology as Docker, which we have built using the Docker image. Now, once we come back to Kubernetes, Kubernetes is all about the system where we will deploy this develop container apps, Docker develop container apps. So now the question is, what exactly I should do as a DevOps engineer? You should be primarily taking the responsibility of managing the cluster, that is provisioning the clusters, deploying the container apps into deploying the Docker images into the cluster. So it is better to go ahead and have an idea about the architecture. So the architecture of Kubernetes comprises of API server, which is the way to connect to the cluster. Maybe you can use a UI or kubectl. Kubectl is very much recommended, the CLI. Are we good in participants enough? Are we good enough at this moment with this information? Shall we proceed further? Okay, thank you. Now, what is meant by a pod? So let's imagine a scenario where you guys develop a Docker image and you ask me to deploy it. You are developers. You gave me the image. So what I have done, I started to deploy that image in both the nodes, node 1 and node 2. Node you can treat now as is an EC2 instance or a cloud instance, an instance. So node 1 and node 2. So what I've done, I started to go ahead and deploy this image and started to run inside my EC2 instances. So this is container 1 and this is container 2. The same image, 2 copies, container 1 and container 2. After that, there is another set of application I started to run, which is C1 prime, and the other one is the same application C2 prime. Now I started to notice that over a period of time, this container C1 prime as well as container C2 prime started to use little more resources than what it is given to it. So what is happening because of this guy started to use more resources. C2 prime started to use more resources like RAM. It is affecting the C1 container and C2 container very much. And I have also come to notice that this is completely taking all the resources away from this guy. C2, there can be, because there is no one to govern them. Govern means no one is responsible to guard them. Now, over a period of time, this container might use all the resources. Very simple example. Let's say this node is of 8 gigs of RAM. This is also 8 gigs of RAM. So we are giving 4 gigs of RAM for this, 4 gigs of RAM for this, 4 gigs of RAM for this, 4 gigs of RAM. So this 4 have started to go ahead and raise up to 6 gigs of RAM. From 4, it is raising to 6 gigs of RAM. So in order to take that, it is deallocated from 4 to 2. And continue this, it is still adding more amount of RAM, more amount of RAM. From 4, from 6 to 8, it is going. So this is almost getting killed. This container is almost getting killed. We are in a situation where the containers are not able to get guarded. So we need something to protect them. That is where pods are brought into picture. So pod is the governing authority which will start focusing on these containers run. So we will go ahead and tell to the pod, hello pod, welcome to Kubernetes. You are supposed to go ahead and run only one container, govern this container. And pod is something inside the pod, we will actually make running our containers. So pod will take care, okay, is this container running? Yes. Is this container running healthy? Yes. Is the image is running healthy? Yes. Is the resources are sufficient? This pod will talk to node, node will talk to master. In this way, there is someone to govern it. So in a nutshell, participants, pod is the atomic unit you get to see in your Kubernetes, which is the smallest unit where your containers run. Containers run inside this pod. So pod is something that you can go ahead and create, that you can manage. So now question comes in. How can I go ahead and can I create my own pods? That is what you have to do. You are required to go ahead and create your own pods. Because you have your image ready, you have your pod ready, you have to go ahead and start using that pod and deploy that pod. So how will you go ahead and talk to Kubernetes cluster? The Kubernetes cluster says, I'm ready to develop the pod which you're looking, but give me what kind of pod should I develop? Or what kind of pod should I create for you? The cluster is asking me, Kumar, I'm interested to work with you. I'll give you the pod you need. Tell me, what is that pod I should use? What is the image should I use? That's a question for me now. So participants, here an example. In this example, I have written to the cluster saying that, dear cluster, I'm looking for a pod to be developed and created. The name of the pod is Hello Pod. And it should use an image called Ubuntu Trusty Image. That simple it is, people, to create a pod. Everyone, are you with me, people? Hello? That simple it is to create a pod. This is a YAML file. This is what we call it as YAML config files. In Kubernetes, 100% of the time, it is very much recommended to write the config files to do your deployments. Anything that you want to do in Kubernetes, things are done using the YAML files. People feel, oh, I can't go ahead and write a YAML file. Participants, you don't need to worry. It's one time that you have to write and you can reuse it. Today, you will learn how to write a YAML file without even having any expertise. It's very, very easy. Only one time you have to write. And how is that you will do it? I'll show you right away. So this is the definition of a pod. When you take pods and do the deployment, what is meant by deployment? What kind of pod you want to deploy? Point number one. And how many number of pods you want to deploy is point number 2. So with these two definitions taken into consideration, that's what we call it as deployment. Deployment speaks that how many number of pods you want. I want 2 pods. One pod on node 1, another pod on node 2, pod 1 and pod 2. Those are replicas. And that's what is the definition of a pod. So this is the definition of a deployment. Don't get scared. I'm telling you, you will be able to do your own deployment by yourself. You can write your own deployment by yourself. Believe me. And once the deployment is created, assuming that you have successfully deployed it, then getting all the pods together and making part of a service to expose to the outside world. What is service? Service is nothing but collection of all those pods that you have created to expose the application to the outside world. We call it as service. I'm going to show you what is service also. So now participants, much of theory, much of discussion. Now it's time for us to explore. So I'm just guessing by now the cluster should have been ready. Cool. Now the cluster is ready, participants. Sigma EKS cluster is ready. Now let's go ahead and understand things one by one. So participants, keeping all the discussions aside, whatever I would discuss, just park them aside. Now, what I want to do is I want to explore Kubernetes. The first thing, hit kubernetes.io. Now it's time to explore by doing hands-on. So we have learned about the definition of Kubernetes. It's a system where we do go and do deployment, scaling, and management of container apps. That means we need to build a container app. So we have built successfully container apps. The container apps, yesterday we have built it. Cool. Now we are ready. Now the question is, where should I go ahead and run this Kubernetes? Now, if you want to do this, we can go ahead and create instance like the one which I've created, then install machines. It's a very, very, very lengthy process, and it's very, very time consuming, and it's not efficient model of running Kubernetes because you have to create instances, scale them. That's not going to work. Then it's time for us to hit our AWS cloud and ask, hey, AWS cloud, do you have anything which is a ready-made cluster for me to run Kubernetes? Then you will end up in something called Elastic Kubernetes Service, the most trusted way to start, run, and scale Kubernetes. So participants, we are required to go ahead and run our Kubernetes cluster on top of EKS. So EKS is a service offered by AWS where you can go ahead and run, your Kubernetes. So it's a managed service. What is meant by managed service? Managed service in the sense it is managed by AWS cloud. Now I have a cluster ready here. Now why did I do this cluster ready? Because if I start now, it will take another 20 minutes for me to go ahead and create this cluster. So that was the reason, people, at the start of the session itself, I ran this cluster saying EKS CTL. So just for your information, participants, EKS CTL is the CLI method which is used to create your EKS cluster. So how to do EKS installation? This command will go ahead and download the EKS CTL tool. It will move into the path. It will go ahead and run EKS CTL. And using this, you will go ahead and create an EKS cluster. So what is the definition of what is the command here? EKS CTL, create me, please, a cluster by giving a name of the cluster, Sigma EKS cluster. What is the region? US East -2. What is the node group name? The name node group is Sigma EKS -cluster NG. What is the type of instances? T2.micro. I've used minimal sizes. To start with, I should have 2 nodes running. And then the minimum number of nodes are required are 2. Maximum, I want to keep them as 5. Access given by using the public key. This is the name of the key pair participants. Remember, this is the name of the key pair. It's not region. This is my key pair. If you are not sure about your key pair, go to your key pairs. Under the key pairs, you should be able to see your key pair. If you look at your key pair, you will find it. I have a key pair which is with the name US East -2. So that is what I have been using, US East -2, and then run this command. This command will take 15 to 20 minutes to create the cluster. The good thing is the cluster is ready for us to explore. You guys can see here, I have the cluster ready. So EKCTL, can you get me clusters? Get me the cluster in the region US East -2. So it gave me the cluster. Under EKS in Ohio region, also you will find there is a cluster that is running. May I have everyone's quick round of confirmation? Participants, everyone, can I have a quick round of confirmation from all of you? Is the cluster, Kubernetes cluster is ready? Participants, are we good? Okay. Now, I said, yes, please continue. Okay. Now, participants, the cluster is ready. I was mentioning about kubectl. Kubectl also installed. What is the command for the kubectl installation? 2 lines. This will download Kubernetes kubectl, and this will go ahead and run the path. With this, your kubectl will be up and running. Those 2 lines are sufficient for you to install kubectl. So kubectl is running. So I said kubectl is the CLI method of connecting to your Kubernetes cluster. See now, kubectl, can you get me nodes? I'm asking it. Kubectl, get me nodes. So kubectl is expected to get me the nodes. See, 2 nodes. Why 2 nodes? The answer is here. We ask EKCTL, create a node group with 2 nodes. Those 2 nodes are brought up by kubectl. Now the question is, how does kubectl will know where to get these nodes from? Participants, everyone, look at this file called .kube folder, .cub. I said there will be a kube folder after the kubectl installation, after the EKS installation. So .kube folder. So cd.kube ls, you see there is a config file, nano config file. So this file has everything inside of it. All the details. Don't disturb the file. So in this file, the details are mentioned. So those details will be used by kubectl. Kubectl is dependent on that file, .config file, .kube/config file. Now kubectl, get me nodes. We already see it is getting the nodes. Now let's go ahead and ask kubectl, hey kubectl, do you have pods? Get the pods. Clearly no pods. kubectl, do you have any deployments? No deployments, because we didn't deploy anything. Okay. kubectl, can you get me my services if you have any services? Except Kubernetes cluster, there are no other services. Now, participants, why we are not having pods? Because we did not deploy anything. Why don't we have deployments? Because we didn't deploy anything. Why don't we have any services? We didn't deploy anything. So without the deployment, don't expect pods, don't expect the real deployments, don't expect the services also. So now it's time for us to go ahead and start thinking, like, how should I go ahead and start doing the deployment? So that is where participant, the Kubernetes documentation will be handy for. So go to Kubernetes documentation and ask Kubernetes documentation, hey, I'm interested to do deployments for my pods. Could you help me? Yes, it will help you. And ask it for deployments that you want to do. Okay, here participants is a deployment. So what is a deployment? A deployment is a declarative way for updates for pods and replica sets. Absolutely right. Declarative means you declare what are the pods that you need and the replicas that you need. So let's go ahead and actually focus on the deployment. Participant, here is a deployment, the way to deploy it. So I'm going to copy this. I'm going to copy this participants, and I'm going to write the deployment file for you. So participants, very, very simple. These two things don't change, API version and kind. Kind means what you want to do. You want to do a deployment. So don't change them. Let it. Metadata is just a name of your deployment. So I'll go ahead and give the name for my own deployment. That is my app-deployment. Labels, what labels are you using for the deployment? I'm using the label app equal to my app. It's just the name. Next, specifications is asking how many replicas you need. Replica means how many pods you need. I'll continue with 3. And I will go ahead and start selecting the labels. Now, what is meant by label? So participants, we have to come a little beneath at line number 23. You get to see a specification. This specification is all about your pod specification. What kind of pod you want to use. So here, pod means what kind of container you want to run inside that pod. Name of the pod, name of the container, my app-container. An image that you want to use. Now participants, image means I can even run a hello world image. That's not our project is all about. Hello world is not the concept here. We have built our own Docker image. But the problem is, where is our Docker image? Can anyone tell me, participants, where is our Docker image? Participants, can you tell me where is our Docker image?
In EC2 machine.
Perfect. It's on your EC2 instance. Now the problem is, what will happen if this EC2 instance gets terminated? Your pod is also gonna get terminated, destroyed. Your image can also get destroyed. So tell me, participants, what is the way to go ahead and handle this image? Then how should I go ahead and handle this image? Because you see, Docker images. I have this image ready. My app is sitting here on my machine. What is the best way to handle this? Can anyone suggest me some kind of solution to handle this? Okay, do not worry, guys. So instead of storing this artifact, which is my app image here, better to go ahead and find a solution where it can be stored. This image can be stored safely. So, correct. We should go ahead and start looking for storing our Docker images. So I can go ahead and ask, hey, AWS, do you have any such service where I can store my container images? Clearly, it is telling you ECR. Container storage for EKS. Now, it is the perfect solution for your Docker images to be stored. So welcome to AWS ECR container registry, participants, which would be used as an artifact storage for storing your Docker images. I want to go ahead and store the Docker images. And the good thing is it's a fully managed container registry. The technical name we call it as, instead of artifact registry, we call it as container registry. Container registry used to store your Docker images, and it's a fully managed service. So what should I do now? Get started. It'll ask you, what is the kind of repository or the container registry that you want? Everyone should see your image. No, I'm not interested to show my image to the world. So don't use public, use private. And the name of your repository, let's say my app ECR. That's it, participants. You need to add one line, a name. Your repository is ready. That's it, participants. Now it is time to push our Docker images inside this ECR container. Agreed, everyone? There is a container registry. Now image needs to be pushed into this container registry. Are we good, everyone? Hello? Participants, are we good? So on your right
Yes,
hand
Kumar.
side, push commands. What is that you should push? Your Docker image you should push. Click push commands. These are the list of the commands. So if you read, you'll get to see that it'll ask you to go ahead and first do a login at line number 1, step number 1. After that, build a Docker image, then put the tag, then push Docker, push this. So let me run one by one. Yep, I'm able to do a successful login into AWS using ECR registry. So it says, hey, there is no such file or directory. It is missing the Docker file. Participants, the Docker file is inside the repo that I've created. This is inside the repo. So let me take into the repo and you will see there is a Docker file. It was not able to build the Docker image because of now it has successfully built a Docker image with the name called myapp-latest. Cool. And now it's time for me to go ahead and tag it. Latest tag. Okay. Thereafter, Docker push. So this will take few seconds to push our Docker image from EC2 onto AWS ECR container registry. Now, participants, the good thing is if you are inside a project, if you are a DevOps engineer, builds a Docker image, using this container registry, you can get a copy of the Docker image. In the real-time projects, this is how things are shared. See, the latest image is available at 7:18. 7:18, the latest image has been successfully uploaded. Assuming that you and me are part of a project, I go ahead and build this image. Now, if you guys have access to this image, you can pull this image, you can run this image. If you are inside the project, in real time, this is how delivery is done. As a developer, I go ahead and write the source code. DevOps engineer will pull the code and build the code, and he will go ahead and build the Docker images for you. So as you are a developer, you can pull this image and run this image. Let me show you people. How will I go ahead and pull this image? So the URI that I want to use is this image. This is the image that I want to use, which is my image. So I want to go ahead and create my own container, my app container using this image. And I want to go ahead and put a label. The label is my app. All your application, whenever any kind of pod is created, because of this, the pod is given a label, and that is the label that would be used by your deployment. So participants, one more time for you. So very simple, participants, don't get confused. These two things, don't make any change. Let it be whatever it is. Metadata, name, my app deployment, the name of the deployment, and the labels that are associated, what label you are using for the meta, so that you will get to know that I have been using a label which is app equal to my app. What are the labels that you now the specific actual specifications is something that you should make. What is that specification? Specification, how many number of pods you need? 3 I want. What kind of pods are you going to select? A pod where the match label equals to my app. Apologies, my app. And what is the template that you want to use for building your pods? The pods should be my app containers, image, and the labels should be attached to them is my app. So participants, I just want to be very sure whether this YAML file is proper. Instead of JSON formatters, you can use now YAML formatters. Yes, cool. YAML formatter is working now. Yes. So I'll go ahead and save this as what we call it as my app hyphen deployment YAML. Same way, after I do a deployment, I need to go ahead and expose it to the outside. So what I'll do, I'll hit back my Kubernetes. Kubernetes, thank you so much. I have been successfully able to write a deployment file. Now I want to go ahead and expose it to the outside world. How do I go ahead and create a service? So hit service, it will go ahead and identify your request that you're looking for a service. Service file is something that you have to create now. The same way that you have created, very simple code. Copy this code now. So very simple now. API version will remain the same. Kind, do not disturb it. Metadata, my app hyphen service. My app hyphen service. The name, give any name you want. How it should go and select? It should go and select with the name of the app equal to my app. It should go and select the name. Name is equal to my app. Name equal to my app. Selection should be based on my app. And the ports, I'm using port 8080. Target ports also 8080. Here, since I'm in cloud, I'll take a little advantage that I want to go and expose it via a load balance. Now, this is extra piece. This is something that I'm adding. Why? Because I'm using a cloud. So I'm going to go ahead and add it as a load balancer. So let me double check participants one more time. Deployments, my app hyphen deployment, name of the deployment, my app, container, my app ECR, cool, service name, Kubernetes selection will be done based on app equal to kubernetes.io, selection, app equal to selection app from kubernetes.io with the name my app and a load balancer. Cool. File, do save as my app hyphen service dot, it's a YAML file. So both the files are created. Now it's time for me to go ahead and submit these files. Participants, didn't I go ahead and save this as a YAML file? File, save as my app hyphen deployment. I'm creating a deployment. YAML file. Now two files I've created. App file, deployment file. So how shall I go ahead and share this file with the system? How is that I go ahead and share this? So you can use anything. I would like to use an S3 bucket, participants. So deployment file, service file. Go ahead and zip this file and I upload into S3 bucket. S3 bucket. Let's use this bucket. Upload, add a file, my app-service. Now I'll get this file downloaded to my system. What is the command? wget. Wget the URL where you want to download. Now the file is downloaded, people. My app-zip file. I'll go ahead and say unzip this my app-file. The two files are available. See, my app.yml file, my app.service file. So now, how to go ahead and do deployment? The command is also mentioned here, people. You can go ahead and say kubectl apply with the force, the name of the deployment. I used Ion as the name, but I'll use now. So kubectl apply the changes with the force for my app-deployment. So it will go ahead and create a deployment for you. Cool. Then we can ask kubectl, did you deploy, right? Can you get me my deployments? Kubectl get deployments. It will show you the list of deployments. As of now, it didn't start. So let me go ahead and check the pods. What are the pods? Yep. It is about to create. It has started with 3 pods. 1 pod is running. Let's keep on checking. Give me a minute, guys. Okay. Let me check one more time. Okay, now 2 pods have been created. So it is pending for another pod yet to get created. Now it's time for me to create the service. kubectl live -f my app-service. So it will go ahead and create the service. Now kubectl, if it has created the service, can you get me my services or service? Cool. Load balancer has come up. So this will also take about a minute for doing the DNS distribution in order to route the traffic. So wait for a minute. So in the meanwhile, participants, I'm going to compile all of this code to you. So this is the deployment file I've already shared, and this is the application deployment. So both the files I'm going to share into S3 bucket. You guys go ahead and give me a confirmation. First thing is the service. Click this link, it will get downloaded. I'm sharing these files with you. And I'm going to share the documentation for the EKS deployment. And by the way, participants, very, very important, EKS is super costly. Very, very costly. So participants, are you able to download?
Yes, Kumar.
Okay. And this is the documentation for your EKS cluster. Check it out. You should be able to download it. Okay. Now, let's explore this one. It should be on port 8080/my app. So it's still not running. Why is that? Let me try it on HTTP. Okay. I'll just check on port 8080. I think we have to figure out participants one. So wait for a minute, participants. It says few instances are not healthy. So kubectl, can you get me my pods? What is the issue with the pods? Okay, one pod is not healthy. We'll do one thing. We'll go ahead and do not. I'll go ahead and check out why it is not healthy. So kubectl describe pod, the pod describe this pod. Why is this pod is not healthy? Maybe space, size. Okay, so it says there are two pods, two nodes available. Okay, we'll do one thing. We'll quickly say kubectl destroy the service. So I will go ahead and destroy the service, my app hyphen service that I've created, or kubectl delete. I would like to go ahead and delete the service, my app. I will rerun the number of pods 3. I will run only 2 pods because there are only 2 nodes. It says it is available. It is not able to create the third pod. kubectl, have you deleted the service? So kubectl, can you go ahead and delete my app hyphen deployment? It will delete the deployment also. My app hyphen deployment. There's a name that I gave. The name is deployment. My app hyphen deployment. Get me deployments. kubectl delete deployment my app hyphen deployment. It will delete this deployment. Yes. So participants, just to keep things very clear, neat, don't use number 3, use my app hyphen deployment. Instead of 3 pods, here the number of replicas are 3, try to create only 2 because there is no sufficient pods. The enter. So participants, whenever you're using, the number should be 2 because it says there are no more nodes that are available because we are using very small size t2.micro. So use only 2 pods at this moment. And it's time for us to run one more time. kubectl, apply the changes, -f, my app deployment. I will do deployment one more time. So it will go ahead and create deployment. Now, I'm sure pods will be very quick. kubectl, can you get me my pods? Okay, one pod is created, one pod is yet to get created. Let's be sure about both the pods, then we'll do a service deployment. Container is yet getting created. Because I've used very small size, I think this is an issue of the small size. T2.micro, because it's free tier, right? So it is taking time to create those pods because there is no space left. Come on. Yeah, cool. Pods are now running. Now, once the pod is running, kubectl, apply the changes and give me a service that I can expose to the outside world. My app -service YAML file. So kubectl, can you get me my services? SVC is also the name that you can use. Load balancer has come up. This will take little time, participants, for the resolution. Even you guys can go ahead and check it from your end. I'll put a HTTP link here. Participants, please do also check at your end. Is it working for you? My app. It will take time. So participants, make sure that you have number 2 mentioned here. If you are using small sizes, number 2 or even 1 is okay for your testing, for your practice, because we don't have space with t2.micro. So let me use another browser like Chrome. Nope, it's not able to receive the traffic. Yeah, now it is resolving people. And then I will resolve the application, my app. It's resolving, but it is not sending the traffic to the application. What is the challenge now? Did I use the latest image correct port? Oh, did I use port 80 here? What service did I use? Port 8080. I think I'll have to go ahead and rerun this at port 80. Give me another 1 minute, guys. Let me go ahead and check at port 80. There's a new load balancer that we have provisioned after the previous load balancer failed to work. Yeah, this is a new load balancer. What are the instances? Out of service. Why is that it is out of service? kubectl get the pods. Pods are running. kubectl, can you get me the service? kubectl get me services output wide. Name equal to my app. It is selecting pods with the name equal to my app. kubectl, can you get me my deployments? I think I have to go and delete one more time. I will delete things, guys. My app hyphen deployment. Delete service. My app hyphen service. ls nano. I'm opening up my app hyphen deployment.yml file. Let me double check name, metadata, label app, replicas, number of 2, metadata, my app, container, image, container port, container port. Let's add this port entry. So is it pulling the right image, participants? Yeah. This is the latest image that I have. Done. And I'll also double check any mistake on the service file. My app hyphen service. Load balancer port 80 app equal to my app service name. All looks good. So kubectl, can you do a deployment for me one more time? My app hyphen deployment. And kubectl, can you go ahead and deploy me my app hyphen service? This time I'm sure things will be very better, participants. kubectl, can you get me the pods? I can confirm you, I can show you whether the application is running or not. kubectl, execute standard input hyphen teletypewriter pod. Inside the pod, I want to get slash bin slash back. Don't worry, I'm not doing anything. I'm just moving inside the pod. I'm moving into the pod. And for your information, participants, CD web apps is available. And the application is happily running here. See, the application is happily running. There is no problem with the app. Exit the pod, back into the machine. So kubectl, I'm awaiting for your service. Yeah, this time I'm expecting a great progress. HTTP and it should go ahead and create me service at my app. Something happening, guys. Everything went fine. Deployment. Load balancer. What is the problem? Why is that you're not able to hit the instance? So load balancer. So out of the two instances, both instances are unhealthy. Why? Why is that? Just I want to add a security group and see, is this your port issue? Is this because of the port issue? Out of service, the instances are out of service. That means they are not able to get the traffic. That means the application is running, but the load balancer is treating them as unhealthy. So what could be the reason behind it? 5 seconds instances. Participants, let me borrow another few 5 minutes. Let me double check the config files one more time. Nano, my app hyphen deployment.yaml file. We double check on this port 80. So kubectl delete my app hyphen deployment delete deployment my app hyphen containers are getting created. Cool, containers now did get created. Any great progress? Can you delete service my app hyphen service and give me a new service? Okay. Here the screen CTL apply the changes from F app hyphen service. I'm deleting and recreating with the changes, guys, every time a service and getting a new service. So keeping in time, guys, effort that I've put in, let me double check the issue. What is the blocker for this? Why it is not getting through? I think there is something which is becoming a blocker. So I'll double check and I'll focus on this YAML files. I think the YAML files are not having the proper way of provisioning the resources. So let me double check. This error, this is not an error. This is basically telling you the services are running in the background, but they are not able to expose to the outside world. That is the only thing. Maybe some port issue. I'm just checking on the port issue. I'll just check and I'll come back to you participants with the solution. So allow me some time. I'll work on this and I'll get back to you about the issue. It's clearly telling me the service is running. I can sense that the service is happily running. The only thing is the data is not coming up because of a port issue. So where exactly that port issue is happening, let me double check and I'll come back to you people. Okay. Is that fine, everyone? Can we come back? Give me some time. I'll come back to you people.
Okay.
Fine, participants.